Hello, everybody. Can you hear me? Sound good? All right. Our MC has stepped away, so I'm going to introduce myself. Thanks for coming to my talk. This is SSH Grabber, which is about a simple hack to sniff Linux passwords from a controlled host. Our agenda for today, we're going to do a very quick introduction. We'll talk about the dependencies for the tool that I wrote and do a little overview about how it works. From there, we'll step through the code, do a bit of code review, see exactly how it does its magic. God's willing, we'll have a live demo after that, so you can see how it actually works. We'll talk about some limitations and criticisms of it after that, and follow that up with a proof of concept, see where this tool would actually be useful. We'll walk through some scenarios where you can actually put it into practice. Then we'll end with a tool release. You can test it, play with it, see how it goes. All right? So without further ado, who am I? My name's John. I'm a network security engineer. I work in the financial industry here in Connecticut. My primary responsibilities are centered around incident response and red team operations. I do have a CISP. I also got to test the Pen Test Plus while it was in a beta phase, which was a very interesting experience. I tried the OSCP. I failed the OSCP, and I'm currently in the process of trying harder. I've been a BSides organizer for the last 2 years. It's good fun. You might have seen me up in the CTF room. If you haven't yet, come check it out. We're having a good time today. I'm a security researcher on my own time. I build shit, I test shit, I break shit. I play a lot of CTF, and according to Hack the Box, I'm a pro hacker, so it must be true. Dependencies. So this tool is written in Bash. It's a simple Bash script, and it's basically got two programs that it depends upon. First one, I bet you're all familiar with, is SSHD, right? A little background on this tool. SSH stands for Secure Shell, and it was designed to replace Telnet, which came before, and the whole purpose of that tool was to allow remote administration of your servers, right? But Telnet was never built for security. Everything, all its authentication, all its commands, everything are transmitted in clear text, which is a problem nowadays because if you're in the middle of the wire, you can see everything going through, you can capture credentials, it's terrible. So they replaced it with SSH. SSH does the same thing, has the same basic functionality, but it adds encryption from end to end on that connection so that you can administer your servers more securely. It uses TLS for that, and it's designed to work with RSA keys. So you've got a key pair for authentication, which you can hand off securely using Diffie-Hellman, and the whole thing is secured. But it's flexible. It doesn't just use keys. It can also work with whatever authentication your OS is using. So it can be local authentication, or it can use PAM, your pluggable authentication module, so you can do LDAP, or whatever else your system is designed to handle. So it's great that way. SSH is designed to be a client-server system. So on the server side, you have SSHD, your daemon, which is running, listening for connections to come in. On the client side, you've got a small program. As long as it's built to work with the protocol, it can interact with the server and establish your connection. Okay? Pretty basic. Dependency number 2 is strace. Okay? System call tracer. This program is designed to show interactions between a process and the kernel. It's a simple debugger. You often find it pre-installed on Linux systems, and it's great because it's super lightweight. It'll give you all kinds of visibility into the process that you're running. Nice thing about strace is that you can use it to spawn a process and then debug it from end to end, or you can attach it to one that's already running, which becomes very useful in this scenario. Normally, SSH doesn't give you any way to view or log the credentials that it's capturing, but you throw strace into the mix, and suddenly, things get a little more interesting. So here's a theory of how this tool works. Pretty simple, honestly. You have a server. It's running SSH, listening for connections. You have a client, initiates a connection to the server, and the SSH daemon forks a process off of that. So it actually runs a separate child process for every connection that comes in, which is great. It can multitask. It's well designed. If you're running SSH Grabber on your server, it'll see that child fork off, and it'll attach strace to it. So now we can start capturing what's coming in. When the client sends its input to authenticate to the server, strace will see that coming in on the socket and calling to the kernel. So now you have visibility into that authentication process. strace logs those kernel calls, then all we have to do is parse the output, and we can get the creds. Easy, right? So let's look at the code. There are basically two parts to the way this script works. First, we find the right processes to attach strace onto, and the second part is we have to parse out the creds. As I already mentioned, SSHD multitask is creating new forks every time somebody connects, so we have to figure out how to attach to those. So the first step here is simple. We have a while loop that runs infinitely, and it uses the PS utility to just monitor the process list. In that list, it's looking for two keywords, SSH and net. Why net? Because that's what we can use to distinguish between the parent process and the children. If it has both of those, then we know it's a child. Once we spot that in the list, we grab the process identifier, and then we use the PID to attach strace to it. Strace has a lot of different options for it, so it's important to make sure we're configuring it in a way that's efficient for our needs. So have a look at the flags there. First one, we have Q, which makes it quiet, which means it's not going to log anything that we don't care about, telling us that it's attaching to a process. It's only going to give us the output. The X flag is important because it makes the contents of the calls that it's logging be output in hexadecimal. Why is that important? Because the logs that come from strace aren't really that nice. And they include brackets, they include quotes, they include other things. And if you're manually parsing that output, it can be hard to distinguish the contents of the call from the other stuff that's logged. If we put the contents in hexadecimal, then it's really easy to extract it without messing up our parser. The S flag here sets the size of our string buffer. This again is important because strace by default only captures 32 characters of whatever call it's bringing in. And this screwed me up for a while when I was writing it because I couldn't figure out why I was only getting partial passwords logged out. Make that string buffer nice and long and you'll get whatever you need. 250 should be good. If you're catching passwords longer than that, feel free to blow it out. The eCall, this is basically a filter for which calls strace should care about. In this case, we only care about writes. And this is just from straight up testing and watching how SSH does its magic. It turns out that all of the user input is being written to the kernel because of the socket. It's being written to the socket. And so that's how the kernel sees it. So anything that's not a write call to the kernel, we don't care about. P flag tells us what process to attach to. We already got the PID from above. And then the O flag just sets the file name of the log that we're going to store this data into. And so what this means is for every child process that comes in, it's going to be generating a separate log file, and that log file will only have the information from that process. So it's nice and clean. The double and means that after the strace process finishes and quits, it'll move on to the next part, which just passes the log file that was created into our parse creds function. Okay? Nice and easy. Now, some of you who are familiar with strace might be asking the question, why didn't you just use its built-in capability to follow forks? And that's a perfectly valid question, because it can do that. The reason why we're doing it this way is because if we use the process to follow forks automatically, then there's only one strace process running the whole time the script is running. It never finishes, which means we don't have an easy way to pipe its output to our parsing function. So if we use, even though this is a little bit less clean, using PS to monitor manually for those processes allows us to pipe the output every time a session closes. Make sense? And if somebody knows a better way to code this than me, feel free to fork this in GitHub and improve it. Now here's a sample of what the output looks like coming from strace. And there are basically 5 components to this. First, we have the name of the call, which in this case it's always going to be write because that's what we told it. We only want to see writes. That second thing, the number that comes right after, is the file descriptor. It's the identifier of where the content is being written to, which in this case is a socket. And again, it's 4 just because testing shows it always ends up being on 4. What we have in quotes after that is the actual content of the call, which you can see is all in hexadecimal. After that, the number you see at the end is the length of the content. And then the final thing after the equal sign is the result, which ends up being the same, the length of the content. Now, anybody familiar enough with hexadecimal to tell me what that actually says? No? Come on. Yeah. So first 4 bits there are nothing. They're just metadata. And the ones bytes, sorry, not bits. The ones after that spell secret. So that was part one. Part two is our parsing function, right? So each log is going to be passed into this so we can try and get the creds out of it. Now, the SSH process, the way it works, when you try and log in, the first thing you do is you send it your username, and then it'll prompt you for a password. You can either pass the username on the command line, or if you have a different client, it'll prompt you when you connect. But username goes first, and then you have up to 3 tries to enter your password. And if you don't get it by the third one, then it just closes out. So this is nice because it means that it'll close cleanly each time. We have a distinction between our logs. So we're going to read the file in and go through it line by line and filter out the lines that we care about. Now, in this case, we already established file descriptor 4 is the one that's being used for user input. So we only care about ones with that file descriptor. The other thing we care about is the length. In this case, we want to make sure it's more than 5 characters long. Why 5? Well, 4, the first 4, we already established our metadata. And this is just part of the protocol that SSH uses. I don't know what they actually do, but it doesn't matter because it's irrelevant to what we're doing. We're just going to skip those 4. But the 5th one, there are also some control plane commands that are 5 characters long. And so it turns out if you just ignore those ones, then you get your user input pretty reliably. So this won't work if you're only capturing a password that's 1 character long, because it's going to ignore it. But if that's your target, then you really don't need this script. So now we've narrowed it down so we can extract the content from it, which is in hex. We're going to drop the first 4 characters off of it, and then we'll do one more check for filtering, right? We're going to check for null bytes. The reason for that, of course, is that if you're sending user input to a service, there should not be any null characters in it. If there are, then you've got other issues going on in your network. But in this case, if you find a null byte, it means that there's another control plane command going through. So we ignore all of those, and what's left should be up to 4 strings. So we convert them to ASCII. Last bit is just to differentiate between the username and the passwords, which I said before is as simple as, is it the first one? Then it's the username. If it's not, then it's a password. So we get those all set up, and that's it. That's the body of the script right there. The actual script has a little bit more because I have to close the loops and increment counters. I also have some code at the beginning that checks your dependencies before you run it to make sure that everything's in line. But otherwise, that's it. Dead simple. All right? So now it's demo time. If anybody wants to fire up SSH and hit that IP address, just give me 1 quick second so I can actually start the process that's listening, and you can see it in action. Okay. So here we go. You can see what I've done is I started SSH, and then I started SSH grabber. If anybody tries to authenticate right now, you should see the username and password drop in. If nobody does it quickly, I'll do it myself. Keep in mind they won't drop until the session closes. So if you fail 3 times, it won't show up until you actually finish the last one. Let's see. Nobody yet? All right. Well, there's mine. Oh, no, that's not mine. Somebody else got one in there. So there you go. That's the tool. It shows you what's going on there. Now, if I cancel this, if it'll let me. Somebody must have a session open. All right. We'll skip that part. I was just going to show that it also, it will log them to a file too, so you can go back and just dump the log to see all your creds later on. So that's the tool. Now, back up. And so let's think about that for a minute. It's handy, it's very simple, it does something very obvious, but there's some problems with it, right? Don't you need root in the first place to be able to run strace on the box? Okay, I mean, if you have root already, you can dump the password hashes, you can change passwords, so who cares? Why does this even matter, right? Also, if you're attacking a box and you compromise the box, maybe it doesn't even have strace installed. Like, so what do you do then? I mean, what if you don't want to install it because you're going to trip somebody's alarm? Also, as we pointed out earlier, this only works for passwords, right? If you're using RSA keys to do your authentication, this isn't going to help you because it won't capture the keys. They're never actually transmitted to the server. That's the way it's designed to work. So, okay, oops. These are all really valid points, right? These are limitations of the script. So when is it actually useful? I mean, the obvious case, of course, is if you compromise a box and it does have strace installed, then you're golden, right? Also, if you can install it, it's just a simple apt-get to get it on the box, and if, depending on your environment, that may not be a problem. But consider this, like what if you have a transient compromise? So you've gotten in through a web server or something else, and you've elevated your privileges to root, but you don't actually have the root password, and you want to get it so that you have easier access to the box. You've dumped password hashes, but you can't seem to crack it. If you can get this on there, you can sit and wait and see if they log in, and then you'll actually have the password in clear text. Also, consider a scenario where they're using PAM instead of local authentication. If they're connected to LDAP, or even better, if they're in a Windows domain, then all the users that are logging into this box are not saving their credentials locally. You wouldn't have any way to get it from the box directly. So if you have this sitting there running, suddenly you can start grabbing credentials off the network. This is getting a little more interesting. What if the host is a bastion? What if this is the box that sits on the edge of the network that grants everybody access into the network and they have to go through SSH? Suddenly this is starting to look a little more compelling, right? Now, proof of concept, right? Even better is when you actually own the box. So consider this. Take a Raspberry Pi, install SSH and SSH Grabber on it, and then drop it in a network. So now you got a rogue host, right? Along comes a spider. Spider is your asset inventory. Okay? This is your process on the network that's going around interrogating every box to make sure it actually belongs there. All right? It's a NAC, Network Access Control. Now, how do these work with Linux? Typically, at least in my experience, they tend to try and authenticate over SSH. And if they can log in, then they know who you are, and they'll either accept that as proof that you belong there, or they'll go on to interrogate you once they have an authenticated account. So this box logs in. Suddenly now you've grabbed the credentials from the NAC. Not bad. And what else have you learned from it? You know the IP address. Now you've got enough information that you can impersonate the NAC. You know the address, you know the credentials. And let me just ask a question, but how many of you work in companies where the service accounts are reused and overprivileged? Yeah, I thought so. So chances are, if your NAC is using password authentication in the first place, instead of RSA keys, like it should do, you've probably just landed some accounts that have serious privilege in the network. So now it's time to do your own spidering, right? Now you've got a Pi that can traverse the network, log into just about anything, or at least anything that's configured with SSH, and get in with likely some pretty decent privilege. This could all be automated, right? With SSH Grabber at the middle doing the credentials, you can easily build this out to do the whole attack stream automatically. And if you add an out-of-band communication channel, suddenly now you got a walking, talking, laterally hopping, network-eating behemoth. So go get the creds. And of course, if you're on Blue Team, it makes a really nice honeypot. So that's it. Tools on GitHub. Go check it out. I hope you like the talk. Any questions? Yes. I'm sure you could, yes. In fact, I think some of the, when I was doing research for this, I'm pretty sure some people have played with that. I hadn't seen them try and do it this way through strace, but PAM modules, you might have a starting point to work with. So, anyone else? All right. Well, thank you very much.